Hello, everyone. Welcome to the What's New in Trusted Single Platform session. I am Raja Balakrishnan. I lead the product team responsible for data governance at Snowflake. Today, I'm joined by my colleagues, Anush and Sam, who will be my co-speakers in this session today. We have several exciting announcements today under multiple categories. So let's get started. Snowflake's single cross-cloud governance model has always been a powerful differentiator, enabling customers to manage their complex data ecosystems with simplicity and ease. To further accelerate this trend, we are enhancing our leading governance capabilities through Snowflake Horizon. Snowflake Horizon is the set of platform capabilities for compliance, security, privacy, interoperability, and access. These capabilities are all provided by default in the platform. Let's take a closer look at each of the pillars of Snowflake Horizon, starting with compliance. We've gone through various certifications to meet industry-specific requirements, such as HITRUST, ITAR, FedRAMP Moderate, and more. We recently added several new certifications that you see on this slide. Additionally, we are also in the process of obtaining more certifications, such as FedRAMP High in GovCloud for AWS, C5 for our German government customers, and TSAX for information security in the automotive industry. In addition to certifications for compliance, we provide various native capabilities to help you satisfy compliance requirements that are internal to your company. Specifically, many of you and many of our customers told us that knowing the freshness and the quality of the data is an important aspect of data governance for compliance, trustworthiness of the data, and risk mitigation purposes. I'm happy to introduce Snowflake Data Quality Monitoring that provides you native capabilities to define your own metrics, automatically measure the metrics on desired tables, and record all measurements in a centralized location in your Snowflake account. We believe that customers like you will benefit from this native approach to data quality monitoring due to better consistency, since you can now define your own metrics and use it across your account. Better manageability, since there are no tasks or stored procedures or jobs to manage. And better privacy, since all metric measurements are recorded in a table in your account. Some of you who have been using Snowflake data governance capabilities over the years are familiar with generally available features such as access history and object dependencies that provide detailed information about the lineage of data objects. Today, I'm happy to announce that you will soon be able to use lineage in the Snowsight UI. Lineage visualization is a powerful technology that can address multiple use cases, such as visually tracking the flow of PII data and identifying downstream dependent objects that will be impacted by change. Lineage UI will enable data governors and data stewards to quickly gain visibility in both the upstream and downstream lineage of an object. It will allow you to drill down to the columns and identify column-level lineage, and you can take quick action to protect all downstream columns with a tag-based masking policy, all with just a few clicks. Let's actually switch to a demo to see both quality and lineage in action. First, we will start by exploring the power of data metrics, such as data freshness, null counts, and invalid email counts. For this, note first that our data quality monitoring comes with a library of predefined data metric functions called system metrics. And you can find all these metrics available in the snowflake.core schema. Null count is an example of a system metric, which is available out of the box. Row counts, unique counts, and there are many more. Also notice that null counts are available on different data types, so you can apply them to different columns of different data types. Of course, you can create your own data metrics, as you can see here. I've already created it, but I want to highlight that we're introducing new system functions, such as the data metric schedule time, which gives you the ability to do a difference between the time at which the metric is executing and the maximum timestamp in your column, so you can identify the freshness of data. Similarly, take a look at line number 20 to 24, which is another data metric for invalid email count, and pay special attention to the regex expression here. The idea is that you should be able to write any pattern matching expression to find the quality of your data. And this is a simple example for email address validation. Now, you can see all the metrics that you've created in your schema by simply using the show command. And you see that we have created 4 data quality metrics for this demo. Now, there are 2 ways in which you can use the data quality metrics or data metric functions. And I want to use the simple table to demonstrate how this works. As you can see here, this table has a lot of data, especially data in the email column contains nulls, and it also contains some invalid email addresses. Now, let's see how you can use the data metric function to monitor and detect these data quality issues. The first way of using data quality metrics is, as you can see in line number 31, is simply use a select statement and pass the any arbitrary column that you want to measure the quality. So let me quickly execute this to show you how this works. As you can see here, all I did was to pass the email column from customers table to the metric, and I instantaneously get the result. I can do the same for null to just show you as an example. And the idea of this way of using data quality metric is so that you can invoke quality metrics either in your data pipeline or simply do ad hoc testing. The second way of using data quality metric is for continuous monitoring. And to be able to do that, first, you have to set a schedule at which you want to have these metrics be monitored, right? And you can see in line number 39 that we are setting a schedule of every 5 minutes for this demo. This could be either a minute or this could be once a day, depending on how frequently you want to measure data quality. I've also associated specific metrics like data freshness, null count, etc., for this demo on this particular table, and all these will execute every 5 minutes. So let me actually show you all of the associated metrics by executing a simple command. You see that there are 6 different metrics that are associated, from freshness to invalid counts to null count on multiple columns. And this is the table, the customer table, and there's a lot of additional information available. In fact, I can also see the schedule at which these metrics will be executed. Now, once the metric executes every 5 minutes, all the results are recorded in a centralized table, which is the data metric results. And I've set up a simple query to simply show you the specific metrics that we showed in the demo, the data freshness and the null check. So let's start with the data freshness here. And you can see that we've been executing these metrics every 5 minutes in the background. And every time we do that, there is a time difference between the maximum timestamp in the column and the time at which the metric was executed. And you can see that the time difference is increasing, which basically tells me that the data is not being refreshed every 5 minutes. As a simpler example, you could do a null check, and you can see that we've also been executing the null check metric every 5 minutes, and again the null count has not changed. In a real world scenario, this could be for you to ensure that every time data is being loaded, you can measure that it's fresh, as well as ensure that the null counts, etc., are not significantly increasing. Now, once you set these metrics and measure them on a regular basis, one of the main things that you may want to do is set up an alert when a threshold is violated. And for that, you could use the alerting framework from Snowflake or the alerts object from Snowflake. The only main thing that we have done here is here where we are basically looking for a time difference of greater than 1 hour in our metric, and then we are alerting or email alerting if that violation happens. Just to conclude this, I want to show you a few examples of metrics that we have already alerted on. Specifically, we have alerted on the data freshness metric, and this is the condition for the alerting, which is what I showed you earlier. We are alerting if there is a greater than 1 hour difference in the timestamp. And the alert logic or the alert body can be anything that you want. In this case, we're just simply notifying that the freshness is greater than 1 hour. Hopefully, this gives you an idea of how you can continuously monitor the quality of your data using native data quality monitoring capabilities, such as the new data metrics function. Now, let's switch to a demo of lineage visualization. In this demo, let's see how a data governor can use lineage to track PII data flow to downstream columns and take action by bulk protecting dependent downstream columns. To do this, let me first start with a search capability. And in this example, I already know the table that contains sensitive information. So I'm simply searching for this table, and here it is. So now I'm on the object details page of the table that I'm interested as a data governor. You will notice here that there is a new tab called lineage, and this provides a lot of good information for data governors. Specifically, you see that I am instantly able to identify that there is a downstream table that is using data from the users table. In fact, I can see that there are even more downstream columns, and by clicking on the plus, I can continue the process and see all the downstream tables or objects that are dependent on the users table. Now, as a data governor, the first thing that I want to ensure is whether there is PII data and how to protect all the downstream columns, right? So to be able to do that, let me click on users. As you can see here, this brings additional information about the table, specifically the columns. And even more interestingly, it also tells me that the email column, which is PII, is tagged, and it is also protected with a masking policy. This is great news, but I want to know whether my downstream tables are protected. Now I can simply do that by clicking on my next table, and here I see that it is in fact not protected, right? It does not have a tag, nor a masking policy. Actually, let's take a quick look at the data to see what's going on here. Okay, so here you see that the email table, email column is not protected. Let me switch back here and then show you what I can do as a governor. Okay, now you see here that there is a new button called View Lineage. As a governor, let me click here, and this brings up a lot of good information for me. And here I'm able to see on the left is my email column, the users table, and I know that it's tagged and protected. All this information is available here. But the most important and interesting piece of information here is that there are 5 columns in various downstream tables at various levels that have the PII information, specifically email address. But you can also see that none of those are tagged, nor do they have a masking policy. As a governor, you want to take quick action. And you can do that by simply clicking the Review Columns button. What this does is it automatically populates the relevant tag and the email address, which we got from the source column. And now, as a governor, you just need to take one action. You have to say, I want to apply the tags. And just like that, all the downstream columns will now be protected with a masking policy. Let's actually validate that. Let's see whether this happened. Let me quickly refresh the screen so I get this back. Okay, so I'm on users. I know this is already protected, but let me click here. Okay, now you notice that the users enriched table, the email column is now protected. Actually, let's double verify this by again going back to this table. And now this time when I go to the data preview, I see that the email address is now protected, right? So you see the power of lineage. In just a few clicks, I was able to get full visibility, and I was able to also take an action by protecting all my downstream columns. Hopefully that demo was insightful to see how our great data governance capabilities are coming together to help our customers. Now, I want to invite my colleague Anush to tell you more about the security pillar of Snowflake Horizon.
Thanks so much, Raja. Hello, my name is Anush Saburi. I'm a principal product manager at Snowflake. I lead all security initiatives from a product perspective. For today's session, I thought maybe it's a good idea to step back and talk a little bit about our philosophy and approach to security at Snowflake, and what are the three pillars that we use here. The first one is about trusting the Snowflake platform with customers' most sensitive data. As you can imagine, moving to the cloud means giving up some control over the hardware, software, and data access. In this new cloud paradigm, it could be very difficult, if not impossible, for customers to have the right guardrails in place to prevent data leakage and adherence to the growing compliance requirements. We at Snowflake provide a data platform that shifts as much of the security tasks in the shared responsibility model, which we'll discuss shortly, from consumers to the providers in ensuring security and compliance. The second pillar for us is around adopting a data-centric security architecture to protect against advanced threats. So as you can imagine, raw data is transformed, ingested into data platform, where it then further used for things like analytics, LLMs, Gen AIs, and apps. These multiple points in the data lifecycle present different opportunities for security attack, as you can imagine. And so what we do is that we secure data access across different things like storage and compute from the moment it is ingested into Snowflake all the way to analytics and Gen AI space. And this approach of having data as being the unit of protection rather than the services is what this differentiates our approach to security. Lastly is our philosophy around reducing Snowflake account risk and minimizing the total cost of ownership in a centralized way across different clouds and regions. So you can imagine there are numerous manual configuration a customer has to do across different cloud providers, and these controls are designed differently. And so it's very easy to make mistakes and drift from the security best practices. We centralize security management for both monitoring the account risk and verifying that the customer is doing their side of the shared responsibility model in one place, regardless of the cloud or region that data is. And this, as you can imagine, reduces the security monitoring costs and minimizes the security attack surfaces, and hence lowering the TCO. Now that we laid out those three principles and foundation of how we think about security within Snowflake, we're very happy to announce the availability of a Snowflake shared responsibility model. This is a framework that clarifies the division of security responsibility between the Snowflake as a platform provider, the cloud solution provider, a CSP, and the customer, right? And with the shared responsibility model, our users can now have a more comprehensive view of their security obligations, as well as measures we at Snowflake have implemented to protect user data. And obviously, you can imagine it fosters transparency and empowers users to actively participate in securing their deployments. And this model span across multiple areas like networking, IAM, and so on. As an example of networking, for example, the cloud service provider is responsible for securing the network layer. We at Snowflake are responsible for configuring things like VPCs and VNets to make sure that the networking stack we use to access customer data follows best security practices. And as a customer, they're accountable to make sure that they configure the network policies using things like allow listing to make sure they reduce the access and follow the least principal privilege. The next set of announcements in our pipeline is around CIS benchmark for Snowflake. So in addition to the Snowflake shared responsibility model, we are very excited to announce our collaboration with CIS to create a benchmark that captures Snowflake's security capabilities and security best practices for our customers. The CIS Snowflake Foundations is a set of industry-recognized best practices and security configurations that help organizations strengthen their security deployments and to verify and ensure that their account adheres to security best practices. So that's another step for us to help customers verify that they're doing the right thing. And putting things together, going back to shared responsibility model, not only we describe the accountability model, but now we have ways to kind of help customer verify them. So at the top of the stack, from a customer perspective, with CIS Snowflake Foundation benchmark, now they have a checklist of things to go after and check. We at Snowflake provide our compliance certificate reports that actually proves that we have followed our side of responsibility model. And similarly, a customer can go to the cloud service provider to obtain a similar set of certifications. And so now there's a framework in place that you can use to verify that everybody's doing what they're supposed to. But that's not where we stopped. We are very happy to announce a soon-to-be available product called Trust Center. This is a centralized risk posture management solution for Snowflake accounts. Trust Center provides a new interface to discover security risks with recommendations on how to resolve them. It does so by scanning the Snowflake account to detect security violations based on CIS Snowflake Foundation benchmark. This is obviously just the beginning for us, and the product will do much more in the upcoming releases. And you can think of it as Trust Center streamlining the cross-cloud security monitoring in one centralized place that, of course, lowers the TCO and prevent escalation of account risk. If you think about the philosophy and the pillars that we use for Snowflake security, this nicely fits into the third category. Now, before I show you a demo of this product to be released soon, I also want to call out a few noticeable releases in the data security. In the case of, let's start with the networking. Today, security admins can apply network policy to restrict access to Snowflake services. In this case, they're leveraging a monolithic list of IP addresses that could be allowed or blocked. As you can imagine, managing this list could become challenging if the number of IPs grows over time. With the upcoming set of network security features now in public preview, admins can now create flexible network rules such as private link identifiers for AWS or Azure that can be referenced inside a single network policy. Private link identifiers like VPC ID or link ID allow for a simplified configuration over purely IP-based restriction. And the good news is these rules can also be able to restrict access to your internal stages that are managed by Snowflake. This applies to S3 and Azure Blob, of course. Additionally, we're launching the isolation to S3 internal stages, which enable isolation of network traffic from customers' environment, whether it's hosted on-prem or in cloud, to the Snowflake services. So a bunch of good stuff in networking layer. In the case of authentication, Snowflake is introducing a set of authentication controls now in PRPR and soon in POPR that allows security admins to customize login experiences by having the identifier first, support multiple identity providers such that it provides SSO, and define authentication controls for different users. For example, data app users can be configured with an authentication policy that only allow connections via drivers and block any login from Snowside. This allows data providers to securely share the dataset and still avoid the risk of data download through the UI. All right, and the last category is in the RBAC. We are now seeing the general availability of database roles. These are Snowflake object types that make access management easier while enhancing secure yet flexible access to data. Database roles also provide ability to have a centralized governance over sharing data as a provider when serving multiple consumers. All right, now let's switch to the demo environment. So here you see the Snowflake web UI, which we call a Snowsite. As you can see, there is a new tab on the left side called Trust Center. And upon clicking on it, you see immediately a set of security insights. The first tab you can see here is called CIS benchmark violations, which basically routinely scans for violations against the benchmark. So in this example, it has been one new finding since the last time the scan happened. As you can also see, there is a quick report of the number of violations against the total number of benchmarks being scanned. And also the violations are color-coded, so you can see based on their severity on how they stand. The other interesting feature of this is a time series representation of this violation, so you can go back in time and see how compliant you were over time, which is very helpful in terms of compliance. We'll get back to the violation quickly, but I just want to also call out two interesting UI or dashboards here. These are not threat per se, but they can provide insights that could, with further analysis, decide to be a threat or not. For example, one dashboard that we show is the login failures by reason over time. So here you can look at the distribution of logins to the corresponding Snowflake account and see the reason for that. And for example, if there is a spike for a specific type and a specific date, might be pointing to a targeted attack on your account, and you can do further analysis based on that. So that's an interesting insight. Another insight that we have here that is also useful is a kind of a breakdown of type of credentials used to access the account. This could be very helpful to assess the strength of the credential used when accessing the Snowflake account. And obviously, the more you use the weak credentials, the higher risk that you may have, right? So a bunch of good insights. And over time, obviously, we're going to expand upon those and provide more and more insights. All right, let's go back to CIS benchmark. As I mentioned, here you have the breakdown and color coding of the violation, but we didn't stop there. We actually proposed and introduced a tab for viewing the violations. As you can see, there are ways to filter them. So for example, based on severity, you can say only show me the medium ones, or you can even type and look for network policy violations as well. So quickly can find the violations that you're interested for. And each violations, if you click on them, it provides more details. So one is the ID that you can share and track with your colleagues. If you have to, you can simply copy that. We talked about the severity level. There's a description of what this does and why it's important. In this case, for example, MFA is not turned on for certain users. And so here you can quickly copy the list of users and do the follow-ups. And that really helps with having a kind of a single place to kind of monitor all these violations and take actions if need be. So that's in terms of the violations and type of filtering you can do. Obviously, one thing we haven't shown in this demo and what we plan to do is to add notification alerting. We do believe that this product, the flow for the users are mainly based on the alerting that starts the flow, and then the admin would visit the portal. So that's something we want to support in the upcoming release to make sure that the customer can set up a threshold, for example, only show me the critical or only notify me of the critical violations. And then based on that, set actions, for example, email being sent out. The other part of this that we haven't shown, we spend a lot of time on the security, but we also want to expand this to consider compliance. One of the things we want to support with this very soon is the ability to download the compliance certificates that our platform provides. If you remember from our share responsibility model, that was the middle tier on that. So as you can see, we're trying to make it easier and easier for you as a customer to verify the share responsibility model, not only for your account, which is the security insight and the CIS scanner, but also the Snowflake as a platform. All right, with that demo, I'm going to pass it to my colleague, Sam, to talk about what's new in privacy space.
Thanks, Anush. Let's take a look at what Snowflake is introducing in privacy. Snowflake's data privacy features, like clean rooms and query constraints, enable customers to safely share sensitive data. We are adding to the set of privacy-enhancing technologies available in Snowflake with differential privacy policies. Differential privacy policies enable collaboration on highly sensitive data while protecting the privacy of people and entities in it. Today, collaboration on such sensitive data is limited. In many cases, data providers must remove information from the data, such as identifying fields and transaction-level granularity. In others, data providers may not be able to share the data at all because of privacy concerns. These steps devalue data and hamper collaboration. With differential privacy, data providers can unlock their data and avoid limiting access or removing information in an attempt to protect privacy. Instead, data providers just need to apply differential privacy policies to tables and views to ensure that analysts can't learn sensitive information. With the policy applied, analysts will still be able to query statistics and aggregates to understand trends in behavior, and they won't be allowed to see row-level data or reverse engineer sensitive information. Snowflake differential privacy is built for use cases with untrusted analysts. What this means is that data consumers can query DP-protected data directly with two constraints. The first is that their aggregate queries will have noise added dynamically. This noise will scale based on how sensitive the query is. For example, for non-sensitive queries on a larger number of records and people, the noise will be statistically negligible. However, if I filter down to one record and ask for an average, for example, the noise will be large in order to protect that one value. The second is that the information that analysts learn through these noisy aggregates is tracked as part of a privacy budget. Let's see a demo of how differential privacy works in practice. In this demo of differential privacy, we'll be looking at how we can use it to enable new analytical workflows on highly sensitive data. Specifically, we'll look at the story of Forage Co., a supplier of high-quality culinary ingredients, and Gourmet Mart, a specialty grocery chain. Forage Co. is expanding and wants to enter California. However, because their supply is limited, they want to make sure that they are placing their products in retail stores that will have the highest interest. Forage Co. has already been partnering with Gourmet Mart outside of California to understand consumer behavior using Gourmet Mart's data. They can't extend these analyses to California because consumers' data is protected by the CCPA. Let's start with Gourmet Mart's data. They have a rich data set about their customers from their loyalty program and store purchases. Here we see two versions of the data set. The version on the left is the full data set. We've preserved the granularity of the data and left all of the sensitive fields intact. This is what we'll protect and share using differential privacy. For comparison, on the right, we have an example of what you normally see without differential privacy. In this version, fields have been masked or aggregated in an attempt to protect privacy. We won't be querying on this in the demo, but let's keep this one in mind as a point of comparison. The first step is to define a privacy policy. In this policy, we are defining a few different access levels. For our own internal data stewards, we'll allow them to run queries without differential privacy. For users in another account, we'll grant them a privacy budget so that they can run queries with differential privacy. All other users will be blocked from running queries by the policy. That's it as far as the privacy piece of configuration. There's no need to identify specific columns that need to be protected. Now let's share this data that we've protected using DP. You can share DP protected data using whatever methods you're using today. Here, as an example, we'll use the native data cleanroom UI and apply a differential privacy policy to objects we're adding to the cleanroom. Once we've published it and shared it, the Forage Co. analyst can install the listing and query the data in the cleanroom that is protected by DP. Now let's switch over to Forage Co.'s point of view. The first thing that analysts will notice when querying a DP-protected table is that row-level queries are not allowed. This is by design. In order to comply with the CCPA, Gourmet Mart can't share data that could be used to identify people, which analysts could easily do if they had access to the row-level data. The good thing is, Forage Co. is not interested in identifying specific people. They want to understand trends and customer behavior. These are discovered not with row-level queries, but with aggregate queries. To protect sensitive information from leaking in the aggregate query results, aggregates have noise under differential privacy. On the right, we have an example of a noisy aggregate result. In addition to the noisy result, the analyst is also given a range so that they can understand the level of noise. The amount of noise added to a query result is dynamic to the level of sensitivity of the query. For example, the query in this example isn't very sensitive. The analyst is querying a large number of transactions representing many Gourmet Mart customers. The amount of noise is small compared to the magnitude of the result. If the analyst had tried to filter down to a very small number of transactions or people, the noise added would increase dynamically to protect their privacy. Let's see what happens when the analyst tries to learn some sensitive information. In other words, a privacy attack. In this example, an attacker has compromised a Forge Co analyst's credentials, and they want to use them to extract sensitive information from Gourmet Mart's data. This bad actor knows that access has already been limited to aggregates, so to try to get around this, they attempt what's called a differencing attack. They are comparing the results of two queries that they expect to differ by only one entity. Here, the attacker wants to target a specific person, Wanda, using information they already have on her from other sources. The attacker is running two queries here. The first is a count of all members, and the second is a count where they are filtering out members who match Wanda's characteristics exactly. If Wanda is in this data set, the attacker expects the difference between these two counts to be exactly 1. Instead, because differentially private count aggregates are noisy, the attacker is only able to calculate a noisy result with a wide range. Here you can see the range is from 0 to 15. Because this range includes the number 0, the attacker doesn't even know whether Wanda is in the dataset. With differential privacy, even though the analyst has access to highly sensitive fields, they weren't able to use them to identify a specific person. Now that we've seen an example of an attack that would be prevented, let's see what the analyst can do with the dataset. Going back to our real Forge Co analyst, we want to know exact locations in California to prioritize for their new market entry. First, they build a customer profile using data from Gourmet Mart customers outside of California. As you can see, this is a detailed profile. All of this can be put together using aggregate queries. With differential privacy, analysts maintain the ability to interactively run complex queries. They aren't limited to a specific set of pre-approved queries, and they don't need to define beforehand what exact queries they want to run. Once they've defined this profile, they can look for customers who match it in California. They can again use aggregate queries to find zip codes in California that have a large number of customers with their target profile. Because these are aggregates per zip code, they can identify specific zip codes to target. I want to bring us back to the two versions of datasets we looked at in the beginning. You'll probably notice now that if Gourmet Mart had shared the traditional de-identified dataset on the right, Forge Co would not have been able to do this analysis because the necessary information has been removed. The only way the Forge Co analysts would have been able to do this analysis in a privacy-preserving way is with differential privacy. Let's recap. In this demo, differential privacy solved two key problems. Number one, it enabled interactive analytics on previously unavailable data, allowing Forge Co to make data-driven business decisions. Number two, it allowed Gourmet Mart to protect their customers and share data in compliance with the CCPA. This demo was just one example in retail. If you're in financial services, healthcare, advertising, any business with sensitive data, consider what differential privacy can do for you. Now I'll hand it back to Raja to discuss what's new in interoperability.
Thank you, Sam and Anush. Those are great new capabilities in security and privacy. Let's now talk about the fourth pillar of Snowflake Horizon, interoperability. Our ecosystem partners play an important role in ensuring that customers like you have the capabilities you need to ensure governance across your data estate. We have worked with vendors in data governance, data catalog, security, observability, and more categories over the past several years to ensure that you can maximize your existing investments and manage your entire data estate through pre-built integrations by Snowflake partners. In addition to our partnerships, we are also investing in open source based catalog integrations. Just to give customers like you flexibility for how Snowflake fits into your architecture, iceberg tables can be managed to use either Snowflake as a catalog to track metadata or external catalogs. In fact, for the internal Snowflake Iceberg tables managed by internal catalogs, we have contributed an SDK to the open source Apache Iceberg project, through which Apache Spark clients can access metadata when reading Snowflake managed Iceberg tables. Additionally, external services such as AWS Glue can also be used as the catalog to track metadata of Snowflake managed Iceberg tables. This is made possible by a new account level object called catalog integration. Catalog integration allows Snowflake to securely read metadata from AWS Glue and object stores. This capability will be in public preview soon. Furthermore, we will soon be adding support for Iceberg's catalog REST API. With the REST API support, Snowflake can read Iceberg tables from any REST-compatible catalog, and REST-compatible engines like Trino, for example, can interact with Snowflake-managed Iceberg tables. The final pillar of Snowflake Horizon is access. As a data analyst, you might have access to hundreds or even thousands of tables, views, and other data assets across your organization. But when you need to answer a question, finding the right data can be half the battle. To help make it easier for discovering data assets, we are introducing Universal Search in Snowsight. Universal Search gives you one place to type what you're looking for, and it returns all the different types of objects that might be relevant to you. We will start with tables, views, native apps, and even Snowflake documentation, and we plan to add even more data assets over time. Now, Universal Search is built by leveraging the state-of-the-art search engine technology that Snowflake acquired from Neeva earlier this year. If you're interested to see a demo of this Universal Search capability in action, please attend the Generative AI for Snowflake Analysts and SQL Developers session. Now, switching back to the data governor's perspective of access. As a data governor, you want to continuously monitor for PII and other sensitive data in your account to ensure that access to such sensitive data is governed appropriately. Today in general availability, Snowflake offers over 50 native classifiers of PII, such as social security numbers, passport numbers, and more. And we support these identifiers across several countries, starting with US, UK, Canada, Australia, and New Zealand. We will soon be adding 2 new features to this category. First, custom classifiers. Custom classifiers will provide you the ability to create your own classifiers to identify and tag sensitive data in your environment. Specifically, you can write your own pattern matching on both the column names as well as the data records in those columns. For example, if you're in healthcare, you can write your own pattern matching to identify diagnosis codes or patient IDs. If you're in manufacturing, this could be identifying part numbers. Second, we are introducing auto classification, a feature that will automatically classify new tables and new columns that are added to a schema. And this is a schema level capability that can be enabled in any schema of your choosing. This capability is now under development. We have covered a lot of details in the past 45 minutes. Just to quickly recap, Snowflake Horizon is a built-in governance solution with a unified set of capabilities. The new features we introduced today joins a long list of existing governance capabilities. And Snowflake will continue to innovate by offering built-in compliance, security, privacy, and access capabilities, as well as support interoperability with other open source catalogs and leading ecosystem partners. With that, we want to thank you for your time and enjoy the rest of Snowday.